In this video, we're going to actually look at what happens when you're not missing the hypotenuse when you're actually missing one of the legs of the right triangle. So we talked about the Pythagorean theorem again, which is your a squared plus b squared equals c squared in the previous examples. Now, what's going to happen here in these examples is that you're not going to be missing c. You're not going to be missing the biggest side. So the question is, how do you go about solving this? Well, if you remember just regular algebra, whenever you want to solve for something, you get it isolated and get it by itself. You move everything that's on that side of the equation over to the other side so that you have what you're solving for all by itself. So what I'm going to do here is, remember, A and B are interchangeable. A and B are both legs. It doesn't matter which one's A and which one's B. In this particular example, this says B. That could say J, it could say K, it could say L, it could say P, it could say X. It doesn't matter. The bottom line is these are your two legs. Well, in order to solve for a leg, we have to rearrange the equation as such. Right now, our equation is written so that we're solving for C, the hypotenuse. So we want the C not to be by itself, but either the A or the B to be by itself. So what I'm going to do is I'm just going to move the A over. It doesn't matter whether it's A or B, and I'm going to do algebra. If I want to get the B all by itself, I move everything around it. And this A squared, I'm going to take and I'm going to shove it over here. So what's going to happen is these guys will cancel. And that's going to leave me with b squared equals c squared minus a squared. Now, this is the version of the Pythagorean theorem that you will use when you are missing a leg. Instead of missing the hypotenuse. So let's look at our piece. Again, it's the same equation. You've just rearranged it. So let's check out our A and B. Well, let's call this B because guess what? It says B. So b squared is what I'm solving for. That's going to equal my c squared, which happens to be 9 squared, and we're going to be subtracting a squared, which is 5. When we are solving for a leg, notice I am now subtracting as opposed to adding. Up here, when I'm solving for c squared, I'm adding the two squared values of the legs. When I'm looking for one of the legs, I'm subtracting the other leg from the hypotenuse. So it's subtraction. So let's work through this. So I've got b squared equals 9 squared is 81 minus 5 squared, which is 25. So I'm going to continue on down here. I've got b squared equals, and there we go. And I'm going to move this up a little bit. We got 81 minus 25, which is going to be 56. Okay. And then once again, remember what we talked about. We don't want b squared, just like we didn't want c squared or x squared. We wanted x. So to undo the square, we square root it. Always finish with a square root. So that square root there is going to be b. And once again, in this video, we are not working with simplifying radicals. We are just actually doing decimal values to make things simple. So you actually get 7.5. And that is your answer. So again, we are subtracting when we are looking for a leg as opposed to looking for the hypotenuse. So let's move down to the next one. Find the value of a. Well, once again, I started off with a squared plus b squared equals c squared. But in this particular problem, I'm not looking for c. I'm actually looking for a. And again, it could be A or B. Just because I have the letter A there doesn't mean it's this one. A and B are either leg. Doesn't matter. But just because it says A, let's make it easy. So what I'm going to do is I'm going to take the B squared and move it to the other side so that I can get the A squared isolated. So a squared is going to equal c squared minus b squared. So now I'm going to plug in using this. Again, you're always subtracting when you're looking for the leg. So let's check this out. All right, a squared is what we're looking for. There's my a. So I know that a squared is going to equal, let's get my c squared, my 25 squared minus my b squared, which is 24 squared. And let's continue down, just like we would with any algebra equation. And guys, 25 squared is 625. And 24 squared is 576. So I'm going to continue on down, just going step by step. 625 minus 576 actually comes out to 49. And once again, I'm not looking for a squared. I'm looking for a, so I have to undo the square. So what am I going to do? I'm going to take the square root. Square root of a squared is a, and the square root of 49 is 7. So there you go. Our missing leg is 7. Last question we have, we're going to kind of apply what we're doing, but we're going to apply it to drawing a figure. So let's draw this figure first. It says the diagonal of a rectangle. Well, let's draw us a rectangle here. In fact, I'm going to draw my rectangle over on the other side, so I have some room here. And pretend for a minute that I can actually draw things of normal length that actually look rectangular. So here's my ugly rectangle. And it says the diagonal of the rectangle is 17. And guys, diagonals of rectangles and squares, let's just get used to it. Those are your hypotenuses, or hypoteni if you want to say it. So that's 17. And it says the length is 8. So we're going to call that 8. Now remember, 8 is, this would also be 8 up here, because it's rectangle, right? So we want to find the length. I'm going to call this L. In fact, if you want to, just to make things easier for you, I'll actually just call it capital L, so you can see it. That's going to actually be our A or our B. So here, I'm looking for a leg again. I'm looking for a leg. I'm not looking for a hypotenuse. If you imagine for a minute that you just have this triangle here, you can see that that is a right triangle. So let's set this up. I want to solve for L. So let's see if we can jump straight into this. I want to solve for L, so I have L squared. I don't know what L is, but since I'm solving for a leg, I'm not going to add. I'm going to subtract. 17 squared minus 8 squared. Now, I just jumped right into it. If you look up at the top here, remember, I wrote the equation out the original way and then showed you how to change it. But if you get good at it, you'll realize when you know the hypotenuse, you're automatically going to set up a subtraction, so you don't have to go through all this stuff. Now, let's follow our progression. So L squared equals 17 squared, which is 289, minus 64. And I'm just going to continue my math, my arithmetic. 289 minus 64 actually gives you 225. And I don't want L squared. I just want L. So how do you undo a square? We've said it so many times before, it seems. You take the square root. And the square root of 225 is 15. So, since I have units on this one also, this is 15 centimeters. Notice there's units. When you have units, put units on your answer. So anyway, this is how you do the Pythagorean theorem when you are solving for one of the legs.